So today we started looking at a new unit, and what we're going to be studying this unit is going to be what we call quadratics. We did talk about quadratic expressions last unit when we were working with just polynomial operations. So we're going to be starting to study quadratics this unit. If you remember, for something to be a quadratic polynomial, it has to have the highest exponent of 2, or a degree of 2. We generally have two forms of quadratic equations that we look at. We have what we call the standard form and the vertex form. All right, so the standard form is going to be ax squared plus bx plus c is equal to y, or y equals f of x equals, whichever notation you happen to be using at the time, but y equals ax squared plus bx plus c. Vertex form is going to be y equals a times x minus h squared plus k. And so that's going to be your vertex form. Notice, squared is the highest exponent. That's what makes it quadratic. These are kind of the two different forms. A, B, C, A, H, and K are just numbers. They're constants of some sort. And so the equations always come in kind of this form of the equation. So that can look like lots of different things. Just a couple of examples. If I have y equals 2x squared minus 6x plus 7. That could be a quadratic in standard form. In vertex form, it might look like y equals negative 2 times x plus 1 squared minus 3. Okay, that could be, a vertex form of an equation. So these are the equations and kind of their parts. It's very important to realize that we refer to A, B, and C as very specific things in the standard form. C is always the constant. B is always the coefficient in front of the x, the term that's to the first power. And A is always the leading coefficient, the coefficient in front of the squared power when we're in standard form. A, B, and C, it does matter which one is A, which one is B, and which one is C. So you want to make sure that you keep those in order. The general shape of a quadratic, now we've done linear functions so far, and when you graphed a linear function, you've got a line. Linear line, that kind of made sense. The shape for a quadratic is a parabola. All right, so the shape of a quadratic is a parabola, and to give just a generic shape to it, it kind of looks like a U. It's one of these curved shapes, and so when you do a quadratic, you have that U shape. Just some basic parts to a parabola that we want to talk about and make sure that we know our vocabulary. The parabola is the U shape itself, so that is what we refer to as the parabola. Just like a straight line, it has things like x-intercepts. Okay, so as far as parts, we do have x-intercepts. You have y-intercepts, where it crosses the y-axis. So we're used to those parts. An important part, though, that is a little bit new is the very bottom point, or in the case of a U that goes upside down, which parabolas can be turned upside down. If you have an upside down U, that would be the very top point. But we call this bottom point here the vertex. It's the point where it turns around. So like it stops going down and it starts going up, or it stops going up and it starts going down. We refer to that as the vertex. It is a critical point, an extreme point. It is where the graph turns around. And so we call that the vertex. It is important to note that a parabola is a symmetrical shape, meaning that it is the same on both sides. It's like a mirror image. So everything lines up and has a partner that pairs up with it on the other side that's the exact same distance away. And so it is a symmetrical shape. It's the same on both sides. And because of that, that means that it has an axis of symmetry. The axis of symmetry is like this imaginary line that goes right through the vertex, right through the middle of it. And if you folded it on that axis of symmetry, it would line up just the same on either side. It's exactly symmetrical around this point, or this imaginary line here. So we call this the axis of symmetry. So we have the parabola itself, which is the actual curve. So it's the parabola. We have our vertex, we have x-intercepts and a y-intercept, and we have an axis of symmetry. So these are kind of the parts. We're going to take a moment and kind of talk about each of these parts a little bit, and how do we find these parts from the equations so that we can actually graph, and what is that going to look like, and how do we find those and stuff like that. But these are your parts that you are looking for. So let's take a moment and discuss the critical point. I called it a critical point. So the critical point for a parabola is the vertex. It's kind of where everything starts. It goes up on either side or it goes down on either side, but everything comes from the vertex. So it's kind of the important point for the parabola. How do I actually go about finding the vertex? Well, you may have noticed that one of the forms is called the vertex form. So it's a good bet that if it's in vertex form, it's probably called that because it's really easy to find the vertex. And that is the case. In vertex form, when you have a times x minus h squared plus k, the vertex form, the reason this is called the vertex form is because h and k tell us where our vertex is. H and k is our vertex. Please note that this is minus h. So that means that we're always taking the opposite of whatever this inside number is with the x. So for example, the k on the outside is positive, it keeps its sign. So we do the opposite of this inside, but we keep the sign of the outside number. So a couple of examples. If I have y is equal to x minus 2 squared plus 5, then I know that my vertex is going to be at 2, 5. If I have y is equal to 3 times x plus 1 squared plus 3, then I'm going to do the opposite of the inside, which would be negative 1, and keep the outside, which would be 3. Notice this number didn't have anything to do with it. That has something else to do with the graph. It kind of determines how skinny it is, or how tall, how fat is the u, or how skinny is the u, but it doesn't affect my vertex, not in the vertex form. If I have y is equal to negative 5x plus 2 squared minus 7. Okay, so I do opposite of the inside, which would be negative 2, keep the outside, which would be negative 7. So that's how we find the vertex for a parabola when it's in vertex form. But if it's in standard form is a little different because we've FOILed this out. We've taken x minus 2 and multiplied it times x minus 2, and then we've added that 5 to it. Kind of screwed us up a little bit. And so we can't just look at the standard form and know exactly what our vertex is. But we can find it. The vertex form is the symmetric point. We do need to go ahead and point out that when you know where the vertex is, you can find that axis of symmetry. The axis of symmetry is always the vertical line that goes through that vertex. So for all of these points, my axis of symmetry, don't forget, a vertical line is always x equals. Horizontal lines are y equals, and vertical lines are x equals. So if I wanted to know my axis of symmetry for these, I'm always just going to say x equals, well, what does the x equal? In this case, it's x equals 2. Here it would be x equals negative 1, and here it would be x equals negative 2. So the axis of symmetry always goes through that vertex. Because of that, it's kind of this neat little average. It's the midpoint. If I pick any 2 points, at the same y value, it's going to be halfway between them. It's halfway between these 2 points. It's halfway between, like it's always halfway between. So finding the x value of the vertex is kind of like finding an average. So how can I use that to my advantage with standard form? Well, if I have y is equal to ax squared plus bx plus c, if I want to figure out where the x coordinate of my vertex is, now this is not the whole vertex, please be aware, this is just the x value of the vertex. The x coordinate of the vertex is always going to be the opposite of b over 2a. We're dividing it by 2. We're basically kind of finding an average. So if I take the opposite of b and divide it by 2a, it's going to give me the x coordinate of my vertex. Now, to find my y coordinate of that vertex, I just have to plug the x coordinate into the equation. I mean, that's what an equation does. It gives us the x and the y value. So once we know what the x value is, we just plug it in and figure out what the y value is. So, for example, let's say that we have y is equal to 2x squared minus 8x plus 7. And I want to figure out where is my vertex for this problem. So what I'm going to do is I'm going to figure out what are a, b, and c. A is always the number in front of x squared, b is always the number in front of the x, the not squared one, and c is always the constant. So opposite of b, so I have to take the opposite of negative 8, which would be positive 8, divided by 2 times a, which is 2. So I'm going to end up with 8 divided by 4, which is 2. So I now know that my vertex is going to be at 2 something. I also know that my axis of symmetry must be x equals 2, since I know my x coordinate. Now to find my y coordinate, I just need to plug it in. So I'm going to take 2, and I'm going to plug it into the equation. Now anywhere there's an x, I have to plug in 2. So I'm going to get 2 times 2 squared minus 8 times 2 plus 7. So 2 squared is 4, and 4 times 2 is 8. 8 times 2, or negative 8 times 2, is going to be negative 16 plus 7. 8 minus 16 is negative 8 plus 7, and negative 8 plus 7 is negative 1. So the vertex for this parabola must be at 2, negative 1. So now I have a way when it's in vertex form that I can find my vertex. I have a way when it's in standard form that I can find my vertex. And if I can find my vertex, then I can also find my x, or my axis of symmetry, because it's always going to be equal to, x equal to whatever that x value is. Other parts of the graph that we want to make sure that we know how to find might be the y-intercept. You know, this is our y-intercept. The beauty of a y-intercept is finding y-intercepts are the same for every single type of function, every single type of equation that we can graph. Finding the y-intercept is exactly the same, because we have to remember what is special about all the points on the y-axis. All the points on the y-axis are 0 something. 0y, this is 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, it's 0y. So if I'm looking for the x-intercept, I'm looking for where is x equal to 0. So anytime I'm trying to find the y-intercept, I just have to plug 0 in for x. Now with vertex form, that actually turns out to be kind of easy. If you remember, vertex form is a equals x minus h squared plus k. All right, so that y-intercept, I just plug in 0, subtract, square, multiply, you know, add these numbers, and I get what y is equal to. I do actually have to do some arithmetic with vertex. I'm going to have to figure out, well, what is 0 minus whatever this number is, or plus whatever this number is, square it, multiply it times a, and get k. But that is a straight up, just plug it in and do the arithmetic. Finding the y-intercept is just going to require some arithmetic. Now, the standard form, however, you don't even have to do arithmetic. Not really. When it's in standard form, if you remember, y equals ax squared plus bx plus c. Well, if I'm plugging in 0, 0 times anything is just 0, which means that this just cancels out, and this just cancels out, and the only thing I'm left with is c. So in standard form, c is the y-intercept. That doesn't work in the vertex form because we're taking the 0 and we're adding and subtracting something to it. So it's not just that number that's out there by itself. But with standard form, 0 times anything is 0, 0 times anything is 0. These just go away, and that means that c is the y-intercept. Finding the y-intercept is super awesome. X-intercepts. A couple of words about the x-intercepts. It's where they cross the x-axis. And so the interesting thing about a parabola is that it doesn't always have x-intercepts. Because the parabola turns around, it's always going to have a y-intercept because it's going everywhere left and right. Those arrows do keep going left and right. Its domain is all real numbers. So it's going to eventually cross over the y-axis. But because we have this vertex, it turns around. So if I have a parabola that's up here, it's never going to make it to the x-axis, and it's not going to have x-intercepts. If I have a parabola that goes down this way, it's starting down here and going down, it's never going to cross the x-intercept or have any x-intercepts. So not all quadratics have x-intercepts. Not all quadratics have x-intercepts. That is not the case. Not all quadratics have x-intercepts. So it is possible that you have a parabola that doesn't have x-intercepts. But that doesn't mean it's going to always be that way. When you are looking for your x-intercepts, what you want to first check to see, so when looking for x-intercepts, factor first. All right, we want to factor it first. If you can factor it, finding the x-intercepts is super easy because the x-intercepts are going to be where they are equal to 0. Because again, all these points are x0. It's where the y value is equal to 0. So when I factor it, I want to find where are those factors equal to 0, and that'll tell me where it crosses the x-axis. So for example, if I have y equals x squared minus 6x plus 8, and I want to find its x-intercepts. Well, I know its y-intercept because it's in standard form. So its y-intercept is going to be 8, right? Because we said that c in standard form is our y-intercept. But I want to find my x-intercepts. So if I'm going to look for my x-intercepts, I'm going to try and factor it first. So two numbers that multiply to equal 8, but add to equal -6. So it's negative, so they're both going to have to be negative. So -4 and -2. So I get x minus 4 and x minus 2. If I want to know where my x-intercepts are, I just have to set these equal to 0 and solve for x. So x minus 4 equals 0. If I just add 4 to both sides, x equals 4. So I have one x-intercept at 4. If I add 2 to both sides, x is going to be equal to 2. So I have another x-intercept at 2. So at 4, 0, and 2, 0 are where my x-intercepts are going to be. Please note, if we do have x-intercepts, we have 2 of them. This parabola has turned around. It's going to cross the x-axis twice, if it crosses it at all. The one exception to that rule would be what if it actually has its vertex on the x-axis. So if its vertex is the point on the x-axis, you do just have one x-intercept, but you can still solve it by factoring. It just usually turns out to be one that when you factor it, you get the same factor. For example, y equals x squared minus 10x plus 25. When I factor this, two numbers, oh, that was 25, excuse me. two numbers that multiply to equal positive 25, but add to equal negative 10, so it's negative, they're both going to be negative, 5 and 5. Negative 5 times negative 5 is 25, and negative 5 plus negative 5 is negative 10. So this would be x minus 5 and x minus 5, which means that when I find my vertex, or when I find my x-intercepts, I get x equals 5 both times. It only has one x-intercept. Its y-intercept would be 25, and its x-intercept would be 5. So you either have two x-intercepts, you have no x-intercepts, or you have one repeated x-intercept. It's that vertex. It's hitting it in that one point. But this is some information about your x-intercepts. Now, if it is not factorable, we can use our calculator to actually show us what our x-intercepts are going to be. For example, if I have y equals x squared plus 8x minus 3. All right, so if this is my parabola, there's not two numbers that I can multiply to equal negative 3 and add to equal 8. It's not factorable, so I can't factor it. So what I want to do to try and find its x-intercepts is I am going to use my calculator. If I go to y equals and I type in x squared plus 8x minus 3, and then graph it, I can see that it does in fact cross the x-axis. So it's not one of those cases where it doesn't cross the x-axis. But it does in fact cross the x-axis, and if I want to find the x-intercepts on the calculator, I go to second trace. This will find all kinds of things on the graph for us. But the one we are interested in is what we are calling a zero, because think about it, x-intercepts are where y is equal to 0. It's where it's crossing 0. So we want to find the zeros. When you do this on your calculator, we want it to find that point for me. So it's asking me for a left bound. I just want to pick a point on the left of it, and then I'm going to use this to move over to a point on the right of it and hit enter. Don't guess, just hit enter, and it will tell me that its x-intercept is at 0.36. Now I have to do it again, second trace 0, but this time I'm going to come over here and I want to find this point. So I'm going to pick a point, let's see, here we go, pick a point to the left of it, hit enter, pick a point to the right of it, hit enter again, and that's something like negative 8.36. So I got positive 0.36 and negative 8.36 for my x-intercepts. So you can use a calculator to help you find the decimal ones or to see if it doesn't cross it at all, but it's much easier if it's factorable. So I always try to factor first and then use my calculator.